In today's video, we're going to discuss this Numitron tube you see before you, counting away. This is a 7-segment incandescent filament arrangement. This particular one is kind of a rare in the end view. It's the DTF 104B made by RCA. We zoom out a little bit here. I'll bring you up this close up here. RCA. DTF 104B. Kind of worn off over the years. There's a date code on here somewhere. I think it was, yeah, is that 9th week of 1975? Now, you can see the 7 segments like any other Numitron tube, suspended by posts. And on the lower left, you can see where there is potentially a spot for the decimal point, which is usually just an X in shape. You use 9-pin, a little bit larger than its relative. Your side view Numitron, which most of you are familiar with, the DR 2000, 2010, which this one is. I think the difference there being this has a decimal point, the 2000 does not. A couple others in this book here. 2100, 2200, just a couple different variations. And we have going on here is this Heathkit Logic Designer Experimenter, and I just set up a simple little counting circuit with a 7490 decade counter, and this package here is your 7490 that outputs 4 lines of binary coded decimal and feeds the decoder driver here, which converts the binary coded decimal into 7 segments, which then drives the display tube. The 7447, which is more common than what I'm using here, this is the 74LS247, which has a slight difference to it I'll get to in a second. But they provide a active path to ground. So your common pin on your display tube will be supplied by your positive rail, and then the switching is done by this decoder here, and then provides the path to ground for return path. This Logic Designer has a nice clean clock output. That's why I'm using it to feed the 7490, and it just provides a 1-second pulse to then clock the counter to drive the display decoder, and that's the result. Getting back to the difference between the 7447 and the 74LS247, it's the way the decoding is done. If you look here, pay attention to the 6 and the 9s. 3, 4, 5, 6. See the top on the 6, and the bottom, the 9 also has a bottom to it, also referred to as tails. The 7447 does not provide the tails on your display like the 74LS247 does. I prefer that. It's kind of neat. You don't see the 74247 too often. Mostly the 7447 was used. For whatever reason, I don't know. I think this is a nicer decoded output for your digital display. I get these in focus here. And this is what I'm using with the 7447 being the alternative. The pinout for the RCA DTF 104B. It's your front view. You're looking at the front view. I'm just going to hold this here for you guys. You can see in the lower left there's an X. That's typically where the decimal point would be. These DTF 104Bs do not have the decimal point. There's no connection there. And then there's your segment connections and your common pin, and there's a large space between the common and the F. That's how you index it. And that's pretty much all we have to say with our pinout. There is no data out there to this point. Here we are in 2023. As you dig online with your Google, what have you, there's some discussions on these tubes, the rarity, the few people that actually have large collections of them, and there's no data. So even Dieter's website with an old display tube data, he's looking for a data sheet on these tubes. So maybe one will turn up one day. So without data, and knowing how these tubes work from playing with the 2000 series a little bit, I had to assume that this tube was rated similar to the 2000 series. So 5 volts, 20 milliamps per segment. Before firing up on this counter and driver arrangement, I did use power supply independently and bring it up slowly, and the filament started to glow, and looks like 5 volts is probably proper for this tube, the way it reacted. But with that said, the rarity of these tubes, and even the 2000 series, I don't like to drive them at their max rating. There are other ways to limit the current and brightness, and the way most of my clocks, and this particular situation we do, I cut the voltage back using a couple dropping diodes. So right in over here, this white wire actually is the common, and through 2 diodes to the positive rail, and that drops between the 2 diodes 1.6 volts and makes that nice orange glow on the filaments. So that's what I prefer to do, only because it's simple. There are other ways, but I figured it's a pretty important note to mention, because there's no data. So for specs out there, maybe that'll help somebody. As far as the part number designation DTF, there is a little note on one of the data sheets for the 2000 series tubes. It could potentially mean development number, and then when they're released for mass production, they get assigned a different number. There's some discussion on that online. like the 2200 series, formerly were known as DTF 137, 138, 139, 140, 141, and then they got renamed 2200, 2210, 2215, etc. So the DTF 104B seems to be one of the largest, measuring in at 1 1/8 in diameter, with a digit of 7/8 of an inch, just under an inch. So that's pretty much all we have to say about this wonderful tube. I do hope you got a little something out of this video, and that I did the tube justice in trying to bring it to your attention out there and to document it. Maybe more of these will turn up on our favorite auction site. Anyway, that's a wrap. Hope you enjoyed, and we'll see you next time.